Hi friends, now lastly for this problem let us look at how this problem can be solved using last in first out way of branch and bound. So the first thing we start is take x1 as 1 and x1 as 0, so we get 2 and 3 nodes. So if these are considered 3 is the last one, so that will be sorted out first. So from 3, if x2 is equal to 1, x2 equal to 0, we get a 4 and 5, and these are the values we can check out. And once 3 is done, next will be 2. So from 2 we get nodes 6 and 7, and minus 38, minus 32, minus 32, minus 22, minus 32, minus 22, minus 30, minus 30 are the answers for that. And once that is done, then we get 2. After 2, what came in? 4 came in, so we extend 4, so that goes to 8 and 9, and we have minus 32, minus 22. For x3 equal to 1, x3 equal to 0, it will be minus 28, minus 28. And for next thing is extending from node 5. With x3 equal to 1 and 0, we get minus 30, minus 18 both cases. So once 5 is extended, the next is to extend 6. So we get these two. Then extend 7, we get these two. So after extending 6, we reach here where we have a value of minus 38. And this minus 38, if you compare with others, so this is minus 32, which is greater than that. So if you extend anywhere in this, it will be either minus 32 or greater than minus 32. Therefore minus 38 has to be the smallest possible. Therefore we prune this, and then looking here, it is minus 22, which is greater than minus 38. So if you extend in the left node, then it will continue to minus 22. If it goes to the right node, it will be even more than minus 22. So you can just look from the beginning. So the left side is minus 32, right side is minus 22. So that way you can see that the things on the left side are greater than the things on the right side. So this is minus 38, so this is minus 22, so we can prune this. This is minus 38, this is minus 28, so we can prune this. Minus 38, minus 22, so minus 22 is greater than minus 38, we can prune it. For minus 28 we can prune, minus 30 we can prune, and minus 18 also we can prune. So we are left with only one node, and that you extend x4 equal to 1, we reach here with minus 38, minus 38, x4 equal to 0, we get to minus 20, minus 20. And in all these things, minus 30th is the smallest thing. Therefore, the maximum profit is the negation of minus 38, that is plus 38. And that is possible for x1 equal to 1, x2 equal to 1, x3 equal to 0, x4 equal to 1. And we get answer of plus 38. 1101. So we look at it, the first in first out 1101, answer 38, and the least count method also said 1101, answer 38. So whatever you do, you're going to get the same. So 1 2 3 4 5 6 7 8 9 nodes were used here, and 11 nodes are used here. And if you look at it here, we have gone up to 17 nodes. So depending on the position of the solution, if it is on the left half, then last in first out is costlier. If it is on the right half, then definitely first in last out is costlier. But whether it is in left half or right half, the least count is going to be always doing the optimal job in minimum steps. So it is always recommended to use the least count method of branch and bound for solving any type of problem. So that we can conclude from looking at these three results. So it's going to build almost the complete tree, whereas this one had built a little comparatively smaller tree, but this one is having smallest possible tree, and the size of this tree doesn't depend on the solution is on the left side or right side of the root node, whereas first in last out, the solution is best if the solution can be found fastest if the solution happens to be on the left of the root or left subtree of this, but it is going to be costlier if the solution was on the right subtree. Same way in the last in first out, if the solution is on the left subtree, it is costlier. If it is on the right side, it is little cheaper, but the uh, one which we call least count is always optimal. So that's what we can conclude in these three types of branch and bound: least count, first in first out, and last in first out. So that's it for now. Thank you.